Hello all and welcome back. So in this video, let us now continue our discussion on list and arrays. And now let's try to implement our own list from complete scratch in Python. Now, till now we have understood what exactly arrays are. We have a very good idea about the concept of OOPS, the inbuilt data structure. In this video and the videos which will follow, I want to just connect all that understanding and want to show you that how we can create our own data structure as well in Python. Now, this might be the first time many of you will be trying to go a lot inside a particular data structure or will try to understand that how things are properly done, okay, the way we are able to use them. So we'll suggest you one thing, that please make sure that you see each and every part of this video very carefully, because once you complete this, then you will have a very good idea on how can we implement any data structure from scratch. The things which we will learn in this particular video, that will be very helpful as we go forward and we implement more complex data structures such as linked list, stack, queues, trees, etc. I will try to explain each and everything very slowly using visualization, as well as making sure that everything is properly understood by you. Okay, you just have to make sure that once I am doing anything, you are also understanding that, and no doubt is there whatsoever in between. So we'll make sure to explain each and everything. But this overall video will be a lot important in understanding that how internally things work when we talk about data structures, something which we will start full-fledged going forward. Okay. So great everyone. Now let us start then. The overall aim of this particular video will be to show that how can we implement a data structure in Python. So if you would have studied OOPS, we saw that how in OOPS we say that using OOPS we have something known as class. Now that class, we used to say that they are custom data type. Custom data type. So this is something which we normally say for class, that hey, class you can think of as a custom data type. So we just like we have integer, list, string, we can create a class person, we can create a class student, right? So that is our data type which we are creating. In a very similar way, we just have to make sure that now we can in create one of the inbuilt data type of Python ourselves, okay, which is list. Earlier, you must have done questions on OOPS where you have to implement a banking system, the complex number class. So there also you would have got an idea that what exactly happens when you're using OOPS full-fledged and how we can write different methods to add any functionality to our data type, right? Or to our class. So that is what we will use. Pretty sure you must have done that question. If not, please make sure that you do that after seeing this video, the questions which were after the OOPS module. Great. So now let us jump back to array and discuss on what were the two things which were kind of shortcomings in array, which were not there in list. The very first one was that array was fixed in size. Array was fixed in size, right? Second thing, and let us though first talk about this one only. Whereas list, there is no such issue. So what happened is that we convert this into something known as dynamic array. The whole idea behind my dynamic array is that as the size of the input will increase, I will take up more memory. So for example, let's say we just start up with a memory which is 2 in size. Okay. Now, if you try to add more than 2 elements, then what's going to happen is it will get double. So let's say it will get increased to 4. Now, if you try to add more elements, it will get increased to, let me do it a little bigger. So it will get increased to say 8. Okay, so 2, 4, 8. Every time we are resizing, I will make sure that I'm copying So we have to copy each and every element, right, back. So let me just draw it in a better way. So we will be copying the elements which we have back to their position. Okay, so this copying is there once we increase the size of our array. So this is how, using this concept is how we are able to add as many elements as we want. I can actually prove that as well to you, that the list in Python, it is a dynamic array, or basically it has a dynamic behavior. Okay. So let us just do one thing, everyone. Let us go to VS Code. So in VS Code, let us just create a list and let me import a module, import sys. Okay. In sys, we have a get size of function which we want to specifically use. So pay attention, everyone. Sys dot get size of L1. And now what I will be doing, I will be adding elements in my list. So I'm writing a for loop through which I will one by one add elements in my list. And I will show you that how the size increases. Okay, so let's say I start from 0 and go till 17. Then I can do L1 dot append I. So this is going to append an integer starting from 0 all the way to 16. And we can also print. So using the F formatting, we can print what I is. Okay. 1 minute, let me, yeah. So I, and for size, we can use sys dot get size of my L1. Okay. So effectively, this code is just creating an empty list. We are getting the size in the starting. Then we keep on appending elements from 0 to 16. And for each element, we are just printing that what is going to be the size. Okay, we should print it here as well so that we can see the size initially. Great. 1 minute, yeah, initial size. And now we should be fine. Let me just close it. Yeah. Great. So we will see the initial size and then we will see how the size increases. Okay, everyone. So let us run this and see what exactly is happening. We started with the initial size of 56. Then we added an element and it increased to 88. Till 4, it was 88 only. After that, it became 120. And till the next 4, it was 120 only. Then I think till the next 8, it will be 184. So we were doubling that. But to make sure that it is not doubled, it keeps on adding by a factor of 4 or 8. Okay. So the major point to mention here is that the size is getting increased, right? So it's dynamic in nature. Yes, you can add anything, but behind the scene, what happened is that a new array gets created, a new memory gets created, or a new list gets created with increased size where we copy each and everything. Okay, and we can see that in front of us as well. Now here they are adding it just for a better memory management. In many languages, it just gets double. Okay, so we multiply the size by 2. And this is the size which we get in bytes. So this is the get size of function, right, everyone? So pretty sure that you must be aware of this function. Get size of give me the size in bytes of anything which I ask. And maybe we can see the documentation as well. Get size of. Okay. So yeah, go to definition. Okay, it is not the one. Should be fine. We can just see. So it just get me the size overall, whatever I ask for that. Okay, great. So now let us go back, everyone, and now see the second problem. The second thing was that arrays in general are homogeneous. That is, only a single type allowed. Okay, great. So what does that mean effectively? In arrays, what used to happen is that we were storing directly what we want, right? So let's say if the elements are 1, 2, 3, and 4, they are directly stored to that memory location, right? So you can go to that memory location and you are going to find 3 here. This is something which is known as storing by value or call by value. Okay, call by value. Now the reason you cannot store any other data type is that when you specify that, hey, I want an array of let's say 4 size, then it creates a memory in which it takes the block size of each block equal to the integer or equal to what you want to store. So let's say if you want to store an integer, it will take 4 bytes and it will just store an integer there. So tomorrow, if you want to store a string which is greater than 4 bytes, then you cannot accommodate that, right? So that is what happened in my arrays by default. Coming to list, in list, instead of storing the values by default, we store their references. So let me just show that as well, everyone. Here, I will be storing where this particular 1 is, where this particular 2 is, where this 3 is, and finally where the 4 is. The references of each and every of these elements are stored instead. And this is something which is known by call by reference as well. Call by reference. Now you can think that instead of storing the value by itself, we are storing the reference. So this reference can point to anything. And let us see that as well. So there is a ID function. Let me just comment all this as of now. See, so if I make a is equals to 1 and I do L1 dot append 1, okay, there is a ID function. So what does this ID gives? It prints the 1 minute. Yeah. So what does this ID gives you? Returns the identity of an object. Okay, guaranteed to be unique among simultaneously existing object. C Python uses object memory address. So all these addresses which I used to talk, you can think that this is the overall address. Okay, where in memory are overall variable or anything is getting stored. If I show you the ID of 1 and if I show you print ID of A, print ID of L1 of 0. So now pay attention everyone, just let me explain you one thing. See what I have done. When we ask Python that, hey, I want to make a variable of A, what does Python do is it's create a value 1 in the memory and gives you back the address. Let's say the address is something like 0x100. 0x because generally we talk in terms of hexadecimal. Okay, so this is just a different system. I prefer to add 0x because it always helps me remember that it is an address. Now when you make, so this A is now also pointing to this address. This L1, when you append, L1 will be saving this particular address as well. And of course, when you print ID of 1, Python knows that somewhere in the memory, it has created this address. So all of them, they are not storing 1 by default, something which happens in other language. They are just storing the ID, the address or reference of this particular object. Okay. So intuitively, you can think of this as that, let's say if you're making a list at your end, you can have any address. It can be a beach, it can be a mountain, it can be a home. But if you want to actually construct them, if you want to save that particular thing, then of course you cannot do that, right? There is a location constraint and everything. So in languages like C++, Java, we are storing the exact element by value. But here we are using the reference. So let us see that everyone. Let me just clear everything and let us run this. And you will see that all of them are having the same ID. What does that mean? That Python is working via reference. So A is pointing to this reference. ID1 is same. ID of A is same. And L1 of this is also same. If I will make A equals to 2 here, then A will just point at some other location and see. This time this and this one is same. But A has now started pointing at some other location, wherever Python must have given it to. Okay. So that's also some important thing to understand. And these are the things which we will be going forward to when we study about data structures and algorithms. So I want to make sure that through this class, you get the basic idea that how we are going to learn things going forward. Okay. So now this thing is also clear. If you can store things by a reference, then it doesn't matter. You are just storing the address. Now it can be a house, it can be a beach, it can be a mountain as well. So it doesn't matter to me because now I am just storing the address. I will go back here, just go to this particular location and return whatever is stored. Okay. Now one thing more, you can understand that normally this is pretty slow. So in arrays, you are just going to that position. You are just going to this position and you have the element here. Here you will go to the position and it will ask you to go to another position. It is little bit slower for very specific use cases where even milliseconds time has a difference. There you might have some performance issue, but in a real world use case, that is like not a big problem. For any web application, mobile application, it will work fine. Okay. So yeah, that is the way we will be now able to get all these things done. Now, what is our aim through this particular in this and the next video is that we want to we want to implement or create our own list. Our own list. Okay. So just like Python is giving us a list and it has different things. Okay. So L1 dot, it has different functions, right? Append, clear. Let me zoom it out. Append, clear, copy. We will try that we are able to implement some of these methods and use them. Now, just to showcase you one more thing, everyone, we can just easily do L1 dot append. Let's say Python. So it's a string and we can print L1 now. And we will see that it is 1 and Python, right? Different things. So our aim now will be that, hey, I want to implement some of these methods, the major one, so that we get an idea that how exactly data structures work in our programming. Okay, great. So let us now continue everyone. And in the next video, we will start with the coding part. For the time being, I want you to understand that these are the major things, okay, which is the difference we talked about in an arrays and list. Again, while doing questions, while implementing anything, we will still use arrays and list synonymously because in a way they are similar only. They are helping me to just store the data, continuous data. So for the end user, no much difference is there. But I have to still showcase to you that list can be very nicely implemented by using the arrays which are present. Okay. So great everyone. Now let's meet in the next video and now start with coding. So please make sure that you have done OOPS exercises, specifically the complex number one, so that you get an overall idea that how exactly these things are going to work and how we are going to then work on our OOPS in creating the class in the next video.